Kia ora and welcome to video 13 in the series Insightful Integration. This problem here is a particular favourite of mine. It involves two tangents generating a region between the tangents and the cubic there, y equals x cubed. So point P, I've drawn it in the first quadrant, although it doesn't specify that it has to be there. A tangent is drawn at that point. It goes across to Q where it meets the cubic again, and then the process repeats. A tangent at Q is drawn, and it heads off back to the cubic on the other side. Call that point R if you want. It's just off the screen because the cubic blows up pretty quickly. Those two regions there, A and B, how do they relate? What is the relationship between them? There is a shortcut to solving this problem. The integration can be a little bit messy, particularly the subbing in of limits and the algebra involved, but if you notice a shortcut, it does definitely quicken up the problem. All the best, and we'll catch you for the solution after the intro music.
This is actually one of my favourite integration problems, and if any of my former students are watching this video, I'm not too sure why they would be, but they'll know that I've used this quite frequently in past assignments. It's quite nice because it's got a shortcut that enables us to solve the problem quicker than intended. We need to find these two areas, A and B, using integration, but because there's a pattern to it, the second time round we don't need integration, we can apply a shortcut. So the region A is the area between the cubic y equals x cubed and the tangent at P. So the first thing we can do is give P some coordinates. So let's say that this point P here is P cubed. So the x value is allowed to vary there. And a tangent has a form y minus y1 equals mx minus x1. So we need to find the slope first. Well, the slope's pretty simple. It's just y equals x cubed. So y dash is 3x squared. And we're finding the slope at the point P. So our tangent becomes y minus p cubed equals 3p squared x minus p. We need that in y equals mx plus c form. So that's quite easy to achieve that. We've got 3p squared x is our linear term. If we expand that bracket out, we've got minus 3p cubed, and then add a p cubed to it, it's minus 2p cubed. That's our constant term. That's our tangent. Now, the second step would be to find the integral between those two functions, between the cubic and this tangent. So if we find the area between is just an integral of a difference, so we can integrate between two limits at the q value and the p value. The top function for this one is x cubed, and the bottom function is the tangent. And we're integrating the difference, the top value of y minus the bottom value of y. We actually do that all the time when we find the area below a curve. For example, this region here, we're actually going the top function, which is y, and the bottom function, which is 0. So we're actually integrating y minus 0 dx. We just don't bother writing the minus 0. Okay, so finding an area between is very simple. Just integrate the difference. We need the x values, I should have been specific there, the x values of q and the x value of p. So we now need a simultaneous equation to find those. Okay, to find p and q, find the limits. Well, we already know what p is, it's x equals p. But the other one is going to be when we solve x cubed equals to the tangent. So we're trying to find out where the tangent meets again. There's a sneaky way to solving this problem. It's a cubic equation, which means it's got 3 solutions to it. But we already know one of the solutions. So we can factor out x minus p. We know that x equals p is a solution to this. And if we factor that out, we get an x squared there. We've got a minus px squared term. Minus px squared term, which we don't want. So if I go plus px, that will sort that problem out. Then we've got a minus p squared x, but we actually want minus 3p squared x. So we need to go minus 2p squared there. That will sort that term out, and then the last one's minus p times minus 2p squared, which is plus 2p cubed. So that's it factored. And then it turns out that the quadratic we've just got also has a factor of x minus p. You can check that by subbing in p into the x value, and you'll get p squared plus p squared minus 2p squared. So that factors again, and the resulting factor, if we do the same thing as before, x squared minus px, we don't want minus px, we want to add a 2p there, and that's going to make that work, equals 0. So therefore x equals minus 2p is the bottom limit. Okay, so let's change our limits now. Minus 2p and p. Let's look at our diagram. Does that actually work? Okay, the diagram looks like p's just a little bit bigger than 2, and the q value is a little bit bigger than minus 4. Yep, or a little bit lower than minus 4. That's cool. Alrighty, so now we work on the integral. We're integrating just a polynomial. So x cubed goes to x cubed over 3. The x term goes to minus 3p squared x squared over 2. I like to write my constants in the front, makes for the easy substitution. And then we've got a plus double negative there, plus 2p cubed, which is a constant. We anti-diff that, we get an x with it. And we're subbing in p here and minus 2p there. Okay, when we do that, I'll leave you to verify this, but it comes out to be 6.75 p to the 4. Now look, we could repeat that process. We could find a new tangent at the point Q, and then find the integral, the difference between the tangent, which is now the top function, and the cubic. Look, we're going to get the same. We get the same integral because it's still going to look like this. The only difference is that where there's a p, it's going to have a minus 2p, and the limits still have the same properties, except this one will be minus 2p, and this one will be 4p, because it's going to flip back around as minus 2 times the other one. So I'll leave you to check this as well, but that's the area A, and the area B is actually just the same thing with a minus 2p replaced with the p, because the first limit we chose originally was p, now the first limit we're choosing is minus 2p. Nothing else has changed, and that's kind of neat, because if you recognize that, then you can straight up say that b is just going to be equal to 16 times a. That's the relationship between b and a. Anyways, hopefully you found that quite insightful, and we'll catch you in the next video.